Welcome. Today the lesson that we're going to be looking at is called Review of Secondary Identities. And so today just gives us an opportunity to go back and take a look at some of the formulas that we've been developing, specifically the sum and difference formulas, the double angle formulas, and the half angle formulas. So we'll really just do one massive problem set here, kind of build it all the way through. We'll try to be as visual as possible as we go through that process. So let's see what I have for you. There's a big example one at the top there, and then there's some space right below the phrasing here and the instructions. So I'd encourage us, let's draw some diagrams out. Definitely a couple we would need, and then a couple I think just for our purposes of being visual with our results. So let's go for it. The way I'm seeing this notes worksheet unfold, I'm thinking 5 coordinate planes would be great. Again, 2 kind of mandatory. So one right here, and again, this is poor form on my part, but I'm just going to put a big alpha on that. And then here, let's get beta. So these are going to be our 2 original angles, and we're going to throw those in place in just a second. And then what we're going to do is combine them together in some way, shape, or form and make a 3rd angle using those original 2. So let's see. I'm going to go 1, 2, and 3 more there, just able to get mine in. And then let's see, the way I have us combining some angles together, I don't have the difference for this one, but there's the sum, alpha plus beta. I see that actually as the first part. And then it looks like we'll do a double angle on alpha, so how about something like that. And then last but not least, let's see, I think I've got a half angle on beta. So something like that. All right. Now again, as I said, the first 2 are the mandatory ones. The last 3 are just to confirm some things that we get mathematically. All right. Well, let's go for it. It says let sine of alpha be 8/17, so a positive sign ratio, and alpha will be in quadrant 2. All right. So let's draw that. To have an 8/17 ratio, probably something like that, give or take. Again, doesn't have to be perfect by any means, but y to r is 8/17. Now remember, please just be very, very careful with your numbers here. When you do Pythagorean theorem, you're going to obviously do an x squared and a y squared equals r squared. Just remember, of course, direction does matter. So I get an x value of 15, but because we're going to the left on that, I do need to make sure that I put it with a negative. Okay, that's great. And again, just so many different ways to go from terminal, or I should say initial side to terminal side. I'm just going to go the primary approach, and we'll call that alpha right there. Okay, good. Let's see. Let's talk beta here for a sec. Cosine of beta is -5/13, and beta is in quadrant 3. All right, so I don't know, something like this, give or take. Bring it on up, of course, and let's go -5/13. So negative cosine ratio, x to r, of course. And let's see, if I go ahead and same thing, do a little Pythagorean theorem, x squared and y squared equals r squared. This is a 5, 12, 13 Pythagorean triple, but no, of course, I am going down, quadrant 3, so that y value is going to be negative. Okay, very nice. And just in terms of drawing beta in, what the heck, something like that is fine. All right, so I now have alpha and beta in place. If I asked you for any of the 6 ratios on either alpha or beta, you would be able to give them to me. Remember, every angle has 6 ratios that go with it, and they're based on the 3 components, everybody, x, y, and r. Okay, well, let's go for it. I think we have some good things in place here. We can write some stuff in. I'm just thinking off the cuff here. If you want to write in just on your paper right away, because I'm not seeing it anywhere there, but I think we will need cosine of alpha. So I don't know if you want to write that there. It might not be a bad idea, which would be -15/17. And then same thing just over here. Well, not ideal by any means, but I'll just kind of put it in. It looks like we're going to need sine of beta, and sine of beta looks like it's -12/13. Again, I think we're going to need that regardless. So put it wherever you'd like. Have a couple of the trig ratios on alpha, and I have a couple of the trig ratios on beta. Okay, now I think we're ready to go, and we'll just go all the way through. So 3 different types of combinations. I've got a sum, a double, and a half for us. And so let's take a look. And it's up to you how you want to play this out on your paper. I'm going to write the formula. I would encourage you to kind of pause the video on occasion, write the formula, write the values that go with that, and then see if you can come up with an answer. But you're more than welcome to kind of wait for me and work half a step behind if you need. So let's go for it. Sine of alpha plus beta. And so this one right here is sine of the first, cosine of the second, plus cosine of the first, and sine of the second. So there it is, sine alpha, cosine beta, plus cosine alpha, sine beta, all of which we know. And so it is time to kind of fill it in. And that's just sort of why I took a moment and did these 2 pieces right here, this one and this one. So I think we obviously are going to need that in order to pull this off. And so you have it on your paper there. I might have to go back a board or 2 and just kind of work that through. But I think I have my results for the most part. All right, so let's give it a try. Sine of alpha, everybody, is 8 over 17. Okay, that was given. Cosine of beta, also given, negative 5/13. Okay, and then a plus. And then let's see, cosine of alpha, I think we solved for, and I got negative 15/17, if I remember correctly there. Hope I have that. And then sine of beta, negative 12/13. All right, and then it's just a matter of us kind of going through. So remember, alpha is your input. When I take the sine of alpha, I just get this ratio right here. I don't want to put anything out in front. It is just a numerical value, y to r. All righty, well, let's see what we end up getting here when all is said and done. I'm going to work just horizontally just so I don't get in the way of some of my other work here on the board. But essentially, I have a negative 40. And then let's see, guys. Let's take a look. 17 times 13. If I have that right, I'm seeing it as a 221. You might want to check that as well. But I'm seeing that piece right there. And then over here, everybody, it looks like I have a 15 times 12, or really negative 15 times negative 12. I'm getting a 180 on that. I'm pretty confident about that one. Should be bringing up my calculator for this. But I'm hoping that's also 221. I'm going to go with it and hope for the best. Okay, and so as a result, everyone, it looks like I have a sine ratio for our new combination angle of 140 over 221. And that's looking pretty good. All right, well, hope, as I said, that 221, I think I have. But I like my numerators there, and so we'll go with that. Okay, letter A, down. Time to take care of letter B. So now again, this new angle, of course, has its ratios that go with it. We're just looking at the primaries, sine and cosine and tangent. And so let's go get the cosine of our new angle here. And so this would be cosine alpha, cosine beta. What do you think, everyone, plus or minus? Minus sine alpha and sine beta. All right, cosine, cosine, minus sine, sine. All the info is right up here. It's the same 4 numbers, just placed differently, of course. So I'm going to run with it up here, negative 15/17. And then let's see, cosine beta, negative 5/13. Minus in the middle, everybody. I have sine alpha, 8/17. And how about sine beta, negative 12/13. All right, not too bad. And so what we need to do here is be able to kind of pull this piece off. Just want to make sure you're comfortable. Again, what I would do is just multiply the numerators, multiply the denominators. I'm going to still go with that 221 there. And negative 15 times negative 5, I'm getting that as a 75 on that end. And then minus, and then let's see, 8 times negative 12, sort of have a negative 96 there over that 221. Okay, very nice. And let's go ahead and combine these together, everybody. So all I'm doing, of course, just order of operations, everyone. I multiply, and then apply the subtraction. And so when we subtract 2 fractions together, of course, we all know we keep the denominator if we have the same denominator, which fortunately we do. And now let's combine the numerators, everyone. I have 75 minus negative 96. So 75 and 96 added together. If you don't mind taking care of that on your calculator as well, I think I have it as 171. Okay, and that is our cosine ratio here. Very nice. Okay, so now letter C, and the way we've been talking about this one, really I should be shortcutting this even further to be honest, but I think it would be something like this, just to be official. So the sine over cosine value. Remember what it's going to come down to, if you can see it as ratios, is just y over x. But I'll play it out here as, the way I said before. So here's our sine ratio for our new angle. Here, everybody, is our cosine ratio of our new angle. And so the 221s, of course, are going to cancel. And I do get what I considered the y over x anyway. 140 over 171. All right. 3 really super ratios right there from combining the two angles together via addition. I did not do the subtraction one on this notes worksheet, but I'm assuming you'd be able to pull it off in the exact same way. Letter D, good question here, and then we'll draw a little bit. Let's see. It says, what quadrant is alpha plus beta in? And remember, that just comes back to the signs of our ratio. So let's take a look at what we got here, the three primaries, everybody. Sine is positive, cosine is positive, and tangent is positive. So which quadrant are all three ratios positive in? I'm seeing it as quadrant 1, everyone, quadrant 1. So let's go back. I'm going to go back a board. You guys just go up to the top there. And so what we're going to do is sort of draw it out in quadrant 1. Interesting. And so I'm seeing it something like this, give or take. Whereas if I draw this, and I'll draw the rotation in just a second, but it looks like if this is 221, then this is 140, and this is 171. Something like that would do. That would be the three values that go together in terms of x, y, and r. Now what the rotation looked like is kind of interesting. Just the way I had drawn these first two, here I went from here to alpha. Then I would add on beta, so I would add on quite a bit more of a rotation. So what I see is after adding those two together, sort of ends up back after a full rotation around, something like this. So just the way I drew it, and again, it's only one of many, but ultimately, it seems like that would be your alpha plus beta. Oh, well, that's very nice. Okay, so we have our ratios drawn in. This added on to that produced this rotation right here. We could, again, there are ways to go ahead and find those angles and kind of work through them. We're not really quite there just yet. So I think just seeing it drawn out there is kind of nice. All right, everybody. So what did we say for this one? Quadrant 1. Don't want to lose track of that. So everyone throw in a quadrant 1 there when you get an opportunity. Sine, cosine, and tangent, all positive. All right, so now the doubles here. Let's go get 2 alpha. And nice, I think letter E is the easiest formula of the bunch. I would say just be careful of one thing. But basically, it's going to be 2 sine of alpha, cosine of alpha. That's it. So the sine ratio on the double angle is just based on the sine and cosine ratio of the original. And so we just, again, want to be a touch careful with this. The way I'm seeing this, and I'm going to write it like this initially, just don't forget, maybe putting that 2 over 1 is helpful there. I've actually seen students over the years sort of do a 2 as like a 2 over 2, which obviously wouldn't make a whole lot of sense. So I just kind of do that to emphasize that piece. Sine of alpha, I think that was given in the problem if I remember correctly. So there it is, 8 over 17. Cosine of alpha we actually had to solve for, of course. And this was in quadrant 2, so cosine was negative. And I seem to recall that as a negative 15 over 17. All right, very nice. And again, pretty straightforward here as it is all multiplication. So I would just multiply the denominators and the numerators together and see what happens. 1 times 17 times 17, I'm getting a 289 on that. And then let's see if I can pull this one off. 2 times 8 times negative 15. Might want to bring up the calculator on that piece, although I think I have it. I'm going to go with a negative 240 from what I see. And everybody, if you can verify that for me, that would be great. Getting a little stubborn here by not bringing up the calculator, but I think I have it. So negative 240. All right, so looks good. Positive 2 times positive ratio times the negative ratio gives us a negative sign ratio there. Keep that in the back of your mind if you would. Okay, now remember this one, everybody. How many variations do we have for the double angle formula on cosine? 3. 3 different variations. You can choose whichever one you like. I've always been partial to this one right here. So cosine squared minus sine squared. I think you avoid some issues there. Just 2 ratios, square them and subtract them, end of story. So I kind of like that piece. That's the one I'm going to play around with, if that's all right with you. If you want to try another one just to see if you get the same result, you're more than welcome to, of course. In fact, I would almost encourage that. But I'm going to play out this one up here. So let's see. We have the 2. So we have cosine of alpha. We have sine of alpha. Now we're just going to obviously do some different calculations on them. So cosine of alpha is this one right here. Remember what cosine squared of alpha means. It means take the cosine ratio of alpha, which is x to r, negative 15/17, and square it. So it's the output squared. Minus, of course, everyone, same thing. Take the sine ratio of alpha, which is y to r, and then square it. Excellent. Now let's just take a peek, see if we can pull this off. I'm getting a 220. I might have to play this out just a little further. 225 over 289 there. 225 over 289 minus 64 over 289. Okay, sounds good to me. And then just do a little subtraction on this. And I'm getting a 161 over 289. Phew. Okay, that's good. Alrighty, so new angle here by doubling the original. We have the 2 primary ratios on it. Let's get the third. And the way we've, of course, played this out, everybody, as long as it is a uniform angle, in this case a double alpha, then it's going to be sine over cosine. So I would do exactly that piece. And you're going to see those 289s cancel out in just a second here, but let's go ahead and lay this out. I have that. And that. Say goodbye to the 289s, everybody. And we end up getting, let's see, negative 240 over 161. Alrighty, good. There are the 3 primaries, of course. We will draw those in momentarily. It looks like on the second page here, so I've got a little break on my board. But if you could kind of turn that over there for just a moment and think about what quadrant would 2 alpha be in. And again, it goes back to just the signs of the ratios, just pretty much some old information here, but now applying it to some of our new angles. It looks like I have a negative sine ratio, I have a positive cosine ratio, and a negative tangent ratio. What's the only quadrant where that would occur? And I'm seeing that, everybody, negative sine, positive cosine, and negative tangent. I'm down in quadrant 4, everybody. Okay, good. Let's sketch it out. Looks like I have my values. Let me just make sure I know those values, okay, because I'm going to have to sketch them. And so here's our 2 alpha, and what did I say? It was in quadrant 4. And let's see, I'm sort of seeing something maybe like, I didn't draw great there, but maybe something like that. Bring that on up, and just pick a point on the terminal side, and the 3 components that would be related together. That was a 289. This was a negative 240. I'm fairly close, so you can see this is going to be kind of closer to that y-axis there. And then this was a 161. Not too badly drawn, all things considered. And so here was our rotation on alpha, everyone. Let's go back to that first one. Here was our rotation on alpha. If I double that angle, you could see that would probably put me down somewhere in that 4th quadrant, exactly the way I drew it here. So I'm seeing that as the rotation. That would be your 2 alpha, of course. Okay, so we've got 4 coordinate planes kind of filled in there. That's looking really good. And then let's do the last, the half. Okay, one more board for me. And here's where we do have to be a little careful. So let's think about this for just a second. Remember, it reverses. So everybody, if you notice, it says what quadrant is the half angle in. We don't, because of that plus or minus. If you remember with the half angles, we have to deal with that plus or minus. And we have to know that kind of going in. So the quadrant idea comes first as opposed to last with the half angles. And so I'm just going to write this, just kind of thinking off the cuff here. If I saw correctly, everybody, beta is in quadrant 3. And so as a result, if you remember, we kind of wrote this on our previous notes worksheet. We had a little rule of thumb, the way I had rotated in quadrant 3 there. Well, half of the angle as a result should be in quadrant 2. So on just the primary rotation, if you take any angle in quadrant 3 and divide it in half, it should end up in quadrant 2. All right, which means, let's draw some conclusions to this so we can roll. What that means for us, everybody, is, let's come right over here. Now, sine is going to be positive of our half angle. Cosine is going to be negative of our half angle. And tangent, everybody, is going to be negative. So that's why we have that taken care of, because we have to go ahead and put either the positive of the root or the negative out of the root when we go ahead and apply the half angle formulas. Okay. All righty. Now, let's go ahead and start the process here. If you remember, first and foremost, I know it is the positive root, so positive out here, and it's 1 minus cosine of beta over 2. Okay, so that's how it's going to play out. It's going to be touch and go in terms of the way I'm going to do this on the board here. I'm going to try to find as much room as possible to work this through. These can get a little hairy, especially working with the fractions and underneath the root, but we're going to make it work here, I'm sure. So let's see if we can simplify this as best as possible. I'm going to have to go back a board because it's all on cosine of beta. I just need to make sure I remember what cosine of beta is. So sorry, just give me a sec. Oh, okay, it was given in the problem. I should have known that. So there it is, everybody. All of our half angle ratios are going to be based on this value right here. Cosine of beta is negative 5/13. So now we can run with it. So here's what I have. Let's go as best as possible. I have 1 minus negative 5/13 and then over 2. As I've mentioned before, kind of want to get rid of the fraction within the fraction. I'm hoping by now, after having done it so often, you're pretty comfortable with seeing what to do here. I personally, to get rid of that sole 13 in this denominator right here, would multiply everything, or kind of distribute in, a 13. So I would multiply this by 13, this by 13, and then this by 13. And that should clean this out right here. We should see this cancel and not have a fraction within the fraction. So let's see if you can pull this off as well here. Some good algebraic skills that go with this piece. A lot of good simplifying. So 13 times 1, everybody, is 13. If you are okay with me doing this, I see a minus a negative, everyone. Minus a negative. So I'm going to immediately put that as a plus. And then, of course, everyone, the whole point of doing that was to cancel out those 13s. So I just get 5. Now down on the bottom, 13 times 2 should be 26. All right, now it's going to be up to you to see what you are able to work with in terms of simplifying. I get 18 over 26, which is not pretty. I wouldn't want to kind of work with this in terms of splitting this up at this stage, because I see a square root of 18 and a square root of 26, and then rationalizing it, that doesn't look like fun. But the one thing that really does jump out at me and might make this a little simpler for us is this fraction reduces. And we are definitely able to reduce it underneath the root. Everybody, 18 over 26, just to get the ball rolling here, I see that as 9/13. If you didn't catch it, that's all right. But that, I think, helps us out quite a bit. Because now, everyone, I'm getting something that's pretty good. I get square root of 9 over the square root of 13. And everybody, of course, that the top should kind of jump out at you off your paper. Square root of 9, everybody, as an integer is just 3. And in essence, everyone, this is our y to r. In fact, when I do my labeling, I will probably label it exactly this way. Y to r, The only thing is, again, just working with rationalizing the denominator. We've been kind of talking about that all semester. Officially, that's how it would look. Okay, not bad at all. I'm hoping you saw this piece, just using this and then getting rid of that little 13 right there, cleaning it out, and then simplifying. It's just good algebra from there. Okay, good. Now, everyone, we do have to be a touch careful. When I do the cosine of beta over 2, I do know, as I said, cosine of this angle is going to be negative. So let's put a big negative out in front here. And then it's 1 plus cosine of the original angle and divide by 2. Okay, we are getting pretty close here, guys. Let's wrap this on up in the next few by doing this one, and then obviously we'll do a little sine over cosine to get our tangent. Okay, so let's see. I think it's going to follow the same path, and I would encourage you to actually pause the video here if you get an opportunity and see if you can walk yourself all the way through. I have a feeling it's going to follow similar steps to this. So as crazy as that looked up there, maybe the second time around it'll click for you. So I'm getting 1 plus. So instead of the 1 minus negative 5/13, very simply it's 1 plus negative 5/13. Same idea, everyone. Can't deal with that fraction within the fraction. So just my way of cleaning that out is just by multiplying everything by that LCD, which of course is 13. So I'm going to distribute 13 into each of these three terms, this one, and this one, and this one. Don't forget, I mean, it's pretty automatic. Just keep putting that negative out in front. And so negative with the root here. And let's see, I get 13 plus a negative, so I'm just going to go minus on that. And then the 13s cancel, so I get 13 minus 5. And then 13 times 2 on the bottom, of course, 26. Okay. So just notice where we are in relation to the last one. It's a minus instead of a plus here. So let's just see how this will simplify. Keep the negative. 13 minus 5 is 8. And again, it's not great at this stage, but I do see some decent numbers because 8 over 26 does reduce. So look to simplify under there. I kind of like that piece. And so I would keep the negative and just go 4 over 13. And I like seeing that 4. And that looks good to me because what's going to happen here, everybody, in terms of working with Pythagorean numbers here and x squared and y squared and r squared, it looks like what I have is going to have to produce this piece up here, long story short. So here's what I have. I got this, and then negative, and there's your integer, guys. That was good. I'm glad that worked out this way. And should have put another equals in the negative there, sorry. So equals negative 2 over root 13, which again is good, and that's my x to r. I'm going to go ahead and call it negative 2 root 13 over 13. And I'm going to box that up, and that's looking really nice. Okay. So take a look, everyone. We simplified all the way through there. Notice I kept the negative every single step. There it is, and at the end. Negative cosine ratio. And last one, everyone, if we just do sine over cosine, we can kind of take care of the fact that tangent should be negative as well. Again, I kind of like this. Here's your y to r. Here, everybody, is your x to r. And so you can kind of see what y to x will be. If you can shortcut this part, that's fine. I've been doing it as sine over cosine, so last time around, so it would be the sine of the half angle over the cosine of the half angle. So just me being official with my values that I did, it would be this piece. But hey, not a big deal here, everyone. 13s will go. As a matter of fact, the root 13s would go. And you get negative 3/2. Not too bad at all. And there are your primary 3 on the half angle, somewhere up in that second quadrant. We'll kind of sketch that out there in just a couple minutes. Okay, well, let's go back and do exactly that, just as I'm thinking that last one needs to be taken care of. And so this would be in quadrant 2. So here's beta, everybody. If you took half of that angle, should end up somewhere here in quadrant 2. So something like this. As I said, there are ways to kind of get these angles there. For our purposes here, we're not going to worry about it. I saw the y to r. I kind of like that 3 to root 13. I kind of like that piece. And then the x would be -2. And there, everybody, would be the rotation on beta over 2. And there are your 5. That's great. So a nice review, just putting it all together. Obviously, as I said, there are some formulas that you kind of have to memorize. So especially sine and cosine, sum and difference formulas, sine and cosine double angle formulas, all the variations on cosine, by the way, and then half angle formulas, sine and cosine. I told you I can compromise on the tangent ones because we're sort of manipulating it in a different way than using the formulas that I gave you. So I will leave that to your discretion, though. But start to put this together a little bit, and you'll have to fill out a blank formula sheet before the exam. So when you fill out that blank formula sheet, you will be able to, well, you'll get points for that. That'll go towards your assessment grade. And then also you can utilize that after in order to do well on the assessment itself. So trying to compromise in terms of memorizing. So all at once, you'll put it on the formula sheet. That'll be the memorization part. Then you can have it out in front of you, and you can use it for the test. So at that stage, you're applying them as opposed to memorizing them. So hope that works. Again, thanks for listening here. I think this is a good review sheet to get you going with these. Let me know if you have any questions, of course.